Now we'll solve one more problem on radioactivity. Uranium ores on Earth at the present time have a composition 99.3% of uranium 238 and 0.7% of uranium 235. The half-life of these isotopes are 4.47 into 10 to the power 9 years and 7.04 into 10 to the power 8 years. These are the half-lives of these isotopes. Assuming that these isotopes were equally abundant when the earth was formed, we have to estimate the age of the earth. See, by using radioactivity, we can estimate the age of the earth. So this is the question. How to start solving this question? We start from the fact that the number of nuclei is given by n0 e to the power minus lambda t. So initially assume that both the nuclei are having number n0 each. So n1, number of nuclei of this, will be n0 e to the power minus lambda 1 t. Lambda 1 corresponds to lambda of U238, say. N2 will be n0 e to the power minus lambda 2 t. Whenever these kind of equations are there, some constants which we want to get rid of, we can just divide one equation by the other. So we can find n1 by n2. This n0 cancels. So what we are left with? E to the power minus lambda 1 t by e to the power minus lambda 2 t. So we'll get e to the power lambda 2 minus lambda 1 t. Right? Whenever e to the power something is there, we can take ln of that and then it becomes a simple calculation. So taking ln of both sides. So ln n1 by n2. When we take ln, this will come to the front and ln of e is 1. So we get lambda 2 minus lambda 1 into t. Ln e is 1. So we can write it, not write it, doesn't matter. Our job is to find t. So from this equation, t becomes ln of n1 by n2 divided by lambda 2 minus lambda 1. n1 is how much? n1 by n2. The numbers of the current time will be in this ratio. So 99.3 by 0.7. So ln of 99.3 by 0.7. And what is lambda? T half is 0.693 by lambda. So lambda will be 0.693 by T half. So 0.693. So now T half is 0.693 by lambda. So lambda becomes 0.693 by T half. So lambda 2 will be 0.693 by T half here. 7.04 into 10 to the power 8 minus again lambda 1. Lambda 1 will be 0.693 by T half of 1. So 0.693 by T half of 1, which is 4.47 into 10 to the power 9. So if we do the calculation, we will get this time as 6 into 10 to the power 9 years. This is the estimate of the age of the earth using this concept. So, in this question, it was told to us that 99.3% is uranium-238 and 0.7% is uranium-235 at the present time. Assuming that these two isotopes were equally abundant when the earth was formed, estimate the age of the earth. We started with the concept that assuming n naught as the initial number of nuclei, n at any time is n naught e to the power minus lambda t. So n1 will be n naught e to the power minus lambda 1 t. n2 will be n naught e to the power minus lambda 2 t. n2 by n1 or n1 by n2 is known. So we can find out n1 by n2, then n naught cancels out. And we get e to the power lambda 2 minus lambda 1 into t. Then we take ln of both sides. And then we solve for t. So t became ln n1 by n2 by lambda 2 minus lambda 1. Lambda is given by 0.693 by t half. T half is 0.693 by lambda. So therefore, lambda is 0.693 by 2 t half. That we substituted in this equation. N1 by N2 is in the same ratio as their percentages. And we got the answer 6 into 10 to the power 9 years.